Hello, welcome back to Mini Rust in Rust. This is video 27, can you believe it? We are currently writing a Rust-like language that's interpreted, and we're using Rust to write it, and we're using this example to drive our current piece of work, basically the while loop, and that stuff is what is kind of interesting about this example. First thing to do is rename this, because I've been getting really confused between Fibonacci and factorial. This is obviously an implementation of factorial, right? You start with a number x and you multiply it by I each time, where I starts off at 1 and goes up until it gets as big as some other number. Anyway, this is factorial. Apologies for the confusion. If I said Fibonacci or fib a number of times, I certainly did in the name here. Shouldn't matter. So it's all about just the syntax. So, how are you doing today? I'm feeling happy today because today I taught my friend the really basic stuff about coding in Python. We wrote a little guess the number game, which is like a classic first program. I love doing that. All right, so we are going to unignore this test and see how it now fails. This is our guiding test that tells us what we need to kind of do next to get this example to work. Notice, by the way, we have got some warnings because in our type checker and in our evaluator, we have this condition in the while loop and we're not doing anything with it. Basically, we haven't implemented type checking or evaluation for while loops, so that's fine. So that's why we got that warning. So the failure that we've got in our example is that currently we have implemented lexing and parsing for while loops, but only if they're empty. And so it's expecting a closing token, a closing curly bracket here, and actually it's getting some other code. So let's ignore our guiding test and write ourselves a more specific test. So what was it that failed in here? It's a parsing error. Yeah, so I think lexing this whole thing now works fine. It's just a matter of parsing it and then obviously evaluating it. So let's try and parse a while loop that has some stuff in it. So let's look at our parser tests. And I think somewhere we've got a parsing of a while loop. Yeah, so we've got a parsing of a non-empty while loop. Let's make another test. So we can call this parse empty while, and this one we'll call, I guess, just parse while would be good enough, wouldn't it? It's kind of, it doesn't have to be a multi-line statement, but yeah, all right, fine. Let's do something different from our example, because we always want to try something different just in case we've messed something up, right? So let's have a let statement in here. And let's have it evaluate to something, just because that's kind of interesting, isn't it? And this is even kind of a valid program, right? It's not a useful program, but it's valid. So this should parse, and it should parse into not just, so it should parse into a while. So this syntax tree colon while means like create me a while syntax tree node. But while at the moment only takes in a condition expression, and it should take in another argument, which is essentially something else, like some, it's like a list of, it's like, it's a thing that I think I want to call a block, which is basically a list of statements that possibly ends with an expression. And the thing that's slightly confusing me here is that I feel like we must have kind of encountered this kind of thing already, because this thing, like a list of statements that might end an expression, is kind of the only thing that we've been parsing so far, right? So we don't have functions and things like that. So Yeah, so let's just write something here and then think about this a little bit more. So our parser right now, it takes in a string. Sorry, it takes in a iterator of tokens, and it returns a parse, which is basically an iterator of syntax tree objects. And yeah, so the point is, yeah, okay, so it's not quite what I was saying, because it takes in just an iterator of statements. And each statement returns one syntax tree thing. Yeah, it takes in an iterator of tokens, and the return value is an iterator of syntax trees, and parse next basically consumes a load of tokens until it's built a syntax tree. And what we want to do is build a syntax tree which is made out of those statement syntax trees. So we need something that's in a way higher level than this thing. So we already have this idea of a statement, which is basically an expression that ends with a semicolon. And when we do that, we make a statement, but we're going to need some other thing, which is a block, which is a list of statements. So I think going back to our something is going to be a new thing, which I'm going to call block. If this doesn't work out, we'll figure it out. So it's going to be a block, and that block is going to consist of, it's either going to consist of a list of statements and one expression, or it's going to consist of a list of things which are either statements or expressions. I think for now, we'll be as explicit as we can, and we'll see whether that works out. So let's say it's a list of statements and then an expression. So here's a list. Inside here is going to be this list of statements, and then here's going to be an expression. So I think we have a syntax tree expression. What do we have in syntax tree? Leaf operation, assignment. Okay, so in this case it's going to be a leaf. Should we have something called expression? It feels a bit odd that we don't. But for now it's going to be a leaf, and the leaf is going to consist of just a leaf token, which is... Now, do we have a constructor for leaf token? No, we just... Oh yeah, we do. We have constructors. Yeah, so it should be a symbol leaf token. We're in the test code, so we can do this. So it should be a symbol, and the literal is AB. So basically, the last statement in this while loop is just a symbol, AB, and the span is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. It's about 28 and 29. That's probably wrong, but anyway. 28, 2. And in here, there's going to be a syntax tree, : statement for the other thing. And statement consists of itself a box of syntax tree. I think this should probably be in a box as well. Anything that is a syntax tree inside a syntax tree, it needs to be a box. Otherwise, we'll get recursive type. So this is going to be a statement. We're going to fix all these compiler errors in a minute, and then it's going to be less annoying. But this is going to be a statement which is just an assignment statement, or assignment expression, I guess. And the assignment is going to consist of a symbol, which is of type symbol token. And just a new symbol token, which is going to be AB, with a span of, well, if that's 28, 27, 26, 25, 24, 23, 22, 21, 20. So it's going to span from 20 for 2 characters. Probably wrong again, but we'll fix that. And is it mutable? No. And does it have a declared type? No. So that's going to be, is that an option, that assignment? Yeah, that's an option, so we can just say none. And the expression is going to be just a 3. So that's going to be another box, right? Yep. So it's going to be a box of syntax tree, : this is just a leaf because it's just a literal. So leaf token. It's just an int literal. So the literal is 3. And the span 21, 22, 23, 24, 25, 25, 1. So basically what we've said here is when you parse this whole thing, it's a while loop. It has this operation, which is the 1 less than or equal to 2. And then it has a new thing called a block, which is a set of statements that live inside curly brackets. And those are going to be one statement, which is a assignment where it says AB equals 3, and then one expression, so not a statement, which is just the symbol AB. So syntax tree should have a block method. So let's make one. Let's put it after the statement because it's kind of bigger. These aren't in alphabetical order or anything. It's going to take some arguments, but for now we'll make where are we? We're in syntax tree and we're making a syntax node because of the hoop jumping that we need to allow ourselves to reuse syntax tree in 2 places. So syntax node of type block. And that means we need to make a variant called block. And what's block going to have in it? Well, in our thing already, we made it take in statements, which are going to be a list of boxed. Well, hold on. These are not a list of syntax trees. This is a list of statements. But a statement itself is just a syntax tree itself. So, all right. So for now, at least we're going to have statements be a vec of box of t. Maybe we can be more specific about exactly what type of thing lives in there. But I think the way our types are structured at the moment, we can't. And then we're going to say it's kind of a final expression. Let's say final expression for now, and we'll see if we can think of a better name for it. So basically, sometimes the final expression in a block is going to be a list of things separated by semicolons. If the last one ends in a semicolon, then there is no kind of final expression. So the final expression will essentially be a unit value or something like that. But we'll say there still is one there. So the final expression is also going to be a syntax tree, and that's kind of making me think, why are we separating them out into a list of statements and a final expression? Why isn't it just the last thing in statements is either a statement or an expression. And based on that, yeah, okay. So it feels a bit unnatural to make this separation. Now I've got to here. So let's try not making the separation and just say a block is just a list of statements. The last of which technically might not be a statement but an expression. So let's just say, what can we say instead of statements? We could just say items or elements or something like that. We could say statements even though it's not precisely correct. We could just say like syntax trees or something, but that seems too vague. Let's go with statements and maybe we'll think of a better name. So when we make a block, it's got to have statements in it. Like so. Which means we've got to take in statements. Which means we're passed in a vector box of T, I think. Oh, self, rather. Right, I think. Let's see. Now, who's moaning? Lots of places where block is not used. Oh, here we're passing in. Yeah, okay. So we're back to, this is where we're trying to make our test. Let's write a test for parsing our while loop. So we had block take in 2 arguments. We've just changed our mind. And this this final expression is just going to be another thing in our list of statements. So put a comma in there, paste our thing in there. And this should be okay. So what is the type of the statements in this block? It should be a vec of box of syntax tree, but we've put statement. Yeah, I guess this should be a box of statement of box of syntax tree. Is that right? Is that how that works? And yeah, okay, block can take in a slice of thing, and then here we're going to like turn it into a vec. I think that's probably a reasonable thing to do. Oh no, this is not a test. This is not a test helper, this block thing. Where are we? We're just making a new syntax tree. Maybe we should take in a vec and pass in a vec. Yeah. Basically, I don't want to make this more expensive than it needs to be. It's going to be a vec on the outside, so why not make it be a vec here? And that means in our test code, we are going to need a 2vec on that. Or in fact, we can just vec it. Okay, what is it moaning about now? Okay, it's moaning about the fact that a while loop doesn't expect to have a block part. It's only expecting to have an expression. So let's fix that. So block should be it should be hold on. No, I keep pressing the wrong thing. Should there actually be a thing called a block, which is a type of syntax tree thing? I mean, I guess yes, because a block is a type of expression in Rust, it can have a value. So a block could actually be used in some other expression. Although in that situation, the curly brackets are part of it. Well, I think they're probably part of it here too. Okay, this might be wrong, but we're going to try it. So obviously in this case, this is the previous test. It's going to need also a block of an empty vec. And this should also be, hold on, what am I doing wrong here? Yeah, this is in the wrong place. This should be an argument to the while function. Something like that. It's confused somewhere, so it's not yet parsing. It's not yet formatting my code for me. We'll get there. All right, so a while loop consists of an operation part and a block part. And a block is a type of expression, which is fine, I think. I think this is going to work out. We'll see. So where is it complaining? Yeah, wherever we make a while loop. So this is the real parsing code, I think. Yeah, we're parsing a while loop, and soon we're going to need to provide this new thing. So let's put to do in here to make it compile. That was wrong. Let's put it to do in to make it compile. And see what other compiler errors we've got, and then we'll come back to that to do. Oh yeah, right. So we hadn't actually said what the thing. So a block is, I guess, a box of self, right? And needs to be stored, which means that syntax node, the while variant of syntax node needs to hold onto a block. So this is kind of weird. Like this is the types are getting kind of erased here. So we know that this is not just a block. No, sorry, this is not just a syntax tree. Like a box of T means this is a syntax tree. We know it's a particular type of syntax tree, which is a block. So we could make this more strongly typed, but instead of saying that block is just a variant here, we could make a struct called block or a block value or something, and then say the block variant of the syntax tree holds onto a block struct, and then here we could say we don't hold on to a syntax tree, we hold on to a block. So we might want to do that. And for a few other places as well, like here, a statement is more specific than just any old syntax tree that we happen to have wrapped up in a statement variant. So yeah, this could get interesting. So let's put a quick to do in here saying maybe use a named struct for e.g. block, so we can be more specific in code that knows we have a block. And that's something we can think about later. So back to what we were doing. There must be a ton of places now that are making a while, not a ton, but some places that are making a while, but not providing. This should be box. Not providing that block, only providing the box colon new, no, box colon view, no. There we go. This was totally wrong. Should be just an empty vec. Okay. What else have we got? Same type of thing here. What's it complaining about? We're passing in a syntax tree when it should have been a box of syntax tree. Right here, I guess. So these extra boxes are a symptom of the fact that we don't know what type of syntax tree. So we have to say a box of syntax tree, because otherwise it would be a syntax tree that contains a syntax tree without any indirection, which would be a problem. If we were specific about the type of syntax tree, that it was a block, we wouldn't actually need this box here, I think. So that in itself might be a good reason to do it. All right, so it's complaining at us that this while never gets actually done because the to-do gets hit. So instead of that, let's put in, I think it needs a box of syntax tree, right? Yeah. So let's put in a box. And it is going to be a block. So let's make a variable called block here. And let's, for the moment, let's say it's empty and just see if we can get this test to fail. Okay, so a few other places where we need to do stuff. Where's it getting blocked from? Oh no, this is in our evaluator. And the evaluator just has a to-do. So it's just saying if you find a while, you need to evaluate, do something, and we haven't yet implemented it. And it's going to be... Oh yeah, and there's another thing as well, which is that there's this other thing called block, which again, we're not going to handle at all. But that's like how should I evaluate a block? Let's get rid of these warnings while we're here. So now we know how to evaluate a block, which is to just crash. And I guess we've got some other places as well, which is, type checking, same thing. And again, we should just suppress the warnings here for now. And again, I've got a new type of thing called a block. Which we're not yet type checking. So, what else? More type checking. No, not that. And let's suppress these warnings too. Same again. While has changed and block is new. So everywhere that we're doing any kind of matching on a syntax tree or a syntax node, we need to update both the while and the new thing, add the new thing called block. Same again. I guess the same again here too. This is just displaying those things. Get rid of the warnings again. So none of this is going to get fixed in this video. We are just going to be parsing that block of statements in a while loop. If we're lucky, if we get that far. Right, so what happens when we run the test? Hopefully now the test will actually run. Yep, so we're parsing a while loop in our new parse while test, which has the same name as an old test, and the parsing code for while loops expects there to be just a closing bracket after the curly bracket. If you've got deja vu, that's because that's where we started, but now we are able to construct a unit test that gives us the same problem, which means we're much more likely to be able to fix it. So here's the unit test we constructed, saying what we should get, and at the moment what we get is a parsing error. So I guess the first thing to do would be to just get rid of the parsing error and make it succeed but fail the test. That might be a useful thing to do, maybe. So here's where we deal with while loops. We look for an opening brace, and then we have a to-do, and then we look for a closing brace. And what we should do instead is some kind of recursive call to say, I guess, parse the next thing. And there should be some kind of stop when you hit type of thing. So we call expression here. So when we're doing parse next, we ask for the next expression, and we say stop when you hit a semicolon, which is actually exactly what we want to do here. And then we look for the next token, and if the next token is a semicolon, we've got a statement. Otherwise, something went wrong is what that's saying. So we want something a bit like this, but we want all the things until you hit a closing curly bracket. So we're going to write the code, and then we're going to see what it shares with this, if anything. So back to our while thing. I guess we want to call a function called block. And that's going to include the opening brace and the closing brace, I'm guessing. So is there some kind of... I think there should be a function called block. And I guess it might fail. And if it doesn't fail, we're going to end up with a block, which we then provide as our part of our return value. So we can get rid of this. And this is going to be, please go and get me a block. And then actually getting a block is going to get refactored into a function called block. Which is going to return similar to whatever this returns. Yet result of syntax tree. Like this. And the return value for now is going to be a syntax tree that we're just going to make up. It's going to be an empty vec again. That should be an OK, shouldn't it? Because this thing returns a result. I'll get rid of this OK that was wrapping that. So basically, same thing as before, we're saying it takes in a token. This doesn't seem right. Surely it's got to pull in a token I guess this must be like previous token is getting passed in here. Because this is actually calling token. Basically, we're calling token to get ourselves the next token, but we need to provide the span of the previous token. So I guess we need a thing called previous token span. Which is basically the same as the token function, which is a usize, usize. And that's what we're going to pass in here. And I don't really think that's what we should be passing in here. We should be passing in brace open.span, I guess. So that was a bit of a bug there. Should have a test for that. All right, so there's still going to be a to-do here for all the statements. Now, we're going to pass in the span of the previous token. No, we shouldn't. We should be passing in condition expression. Maybe. No, that's not a token. So the point of this passing in this previous token span is that we complain about, if we get to the end of the file, we complain saying I got to the end of the file, and we have to say where, and it's here. So this is a little odd because really where is like just wherever it is the end of the file. So actually previous token span is not, we kind of already ought to know this. So I feel like there's some kind of to do here for to do. We already know the location. It's just the last character we read, something like that. No need for previous token span. So I think that's something we should fix later. For now, we are just going to pass in something which is kind of wrong, which is the token that was the beginning of our while instead of whatever's happened after we've passed condition expression. But as I said, all this is used for is to say we got to the end, and here's where we got to the end. So we're just slightly being wrong about where we're saying the end was, which is only happens if the file's like incomplete. You're halfway through a while loop and you just didn't type anymore and the file ended. Which is probably why I haven't caught that with tests yet. Okay, so to do is handling that. Let's check that we should be getting the same test failure as before, because we haven't actually improved anything. We've just factored it out into a function. So now there's a function called block, which looks for an open brace and then expects a close brace. And what we want to do, well, I feel like we wrote some code that like gets a token and then checks it matches a thing, right? Did we do that? Well, here's us doing it manually. Okay, maybe not. All right, so I feel like this is a pattern that maybe we should encapsulate somewhere, but we haven't done it yet. So we'll leave it for now, and we'll look for as many statements as we can. So each time we look for an expression, so it's going to be something like look for an expression, and the end markers that you're allowed, there are going to be 2 end markers instead of just 1. So this is something we implemented anticipating that we're going to be doing this kind of thing and haven't actually done it yet. So let's look for where else we called expression, because we've done this with just, yeah, so we have done this by saying, please get me the next expression, and you'll know it's ended when you hit a semicolon. But the other reason it might end, surely we don't need two sets of square brackets here. The other reason it might end is because we've hit a closed curly bracket. Like so. By the way, the fact that we have to supply a literal here, just to say the kind of thing you might hit might be a semicolon. It's weird that we have to supply this curly bracket and make a string out of it, just to say, when actually all we care about is this type here, this brace closed thing, and the literal will obviously be closed curly bracket because they always are. So these literals inside these token kinds are a little odd, and we have a to-do to fix that, and then I feel like we used one of those last video, which makes it a bit awkward. Anyway, get out an expression. We're going to do this multiple times, right? But for now, let's just do it once. And this expression is either going to be hang on. What does self.expression do? Does it look for statements? I guess not. Yeah, the expression is either a let or a while. Either an assignment statement or a while or some other kind of operation, and it's not a statement. So we want to say something similar to what we said in parse next, which is, if I got a semicolon, it's a statement. If I got a brace close, it's an expression, and we're finished with this block. Something like that. So we're going to be looping around getting all the expressions, putting them into our return value, which is going to be here. So I guess we should build up a vector. So we always need a brace open, so that's all fine. Then we're going to make some kind of return value. Whenever I make something mutable, I think probably there's a better way of doing it. So we'll maybe think about that later. And then get an expression. And if, well, hang on, how did this work? So in the other place where we did this, we had to then check whether it was a semicolon, right? So we got the semicolon out, and we checked whether this expression was actually an error. Is there a better way of doing this? So expr was a result of syntax tree, report. And if it was an error, then we made it be a sum of result. All right, so let's not think about that for a second. That's because of, like maybe it's hit the end, so we don't have to deal with that, I don't think. I'm not sure. But the next thing we did was we got that next token. So basically, expression stops when it hits a semicolon, but then it pushes that semicolon back into the token iterator, so we can just get it out again. So we get it out again, we check whether it's a semicolon, so we're going to do something a bit like this. And it's not quite the same because we don't actually return the answer, but we are going to do, get me out a statement, And if we hit the end, this seems bad. So we're going to return some kind of error, because we need to end with this closing brace, basically. So if we run out of tokens, then we are going to return an error. And what's the error going to look like? It's going to look like we got to the... So it's not an unexpected token, it's a... like unexpected end of file. We've got that right. Unexpected EOF, right? And is that a thing? Let's just comment out this stuff because it's confusing the parser. An unexpected EOF needs this stuff, and then the source is going to look similar to this. We'll think about the span in a second. So source is just going to be that because we haven't done file names yet. And we should do an into on this to turn it into a Miette report. And we need some kind of span, so I guess it's token.span. Like that. Oh, there was no token, so it needs to be previous token or something. Again, we've got to the end. Yeah, let's just use previous token span, even though it's wrong. Again, we got to the end of the file, so we should be saying just go and look up the latest character. That is what. All right, so it's complaining that it doesn't know what vec is, but that's okay. We're about to add something. So we get the next expression, and if you hit a semicolon or a closing brace, stop and give us the expression. Then we get the next token. If there is no next token, something's gone wrong. We can't just end the file there. So we've definitely got a next token. If that token is a semicolon, then we're going to add something to ret. We're going to add the expression, but wrapped up in an operation. So we'll do that in a second. Otherwise, if it's not a semicolon, it's either going to be... So I guess shall we match? Let's match. And there's a lot of things it could be. We only care about a few. So if it's a semicolon, then it's fine. If it's a brace close, it's fine. Otherwise, it should never happen. So we need some kind of should never happen here. And we dealt with a case like this last time, I think, so we'll look at that. Right, so let's try this again. If we hit a semicolon, then we've just found one of the statements in our while loop. So put that statement into our return value. And this is before we did our match. And what we're putting in here, let's just do it, is going to be syntax tree statement. And I think that takes a box, right? Yeah. And the statement is going to be our expression that we just got out. Oh no, expression is an option because, like, it might fail. Why would it fail? Oh, because there were no more tokens. But hang on, we've already dealt with that case. It can't be none now. So express was self.expression. Oh no, we haven't dealt with the case that express was none. It's all right. So we have to deal with that, which we did in the code we're copying, and we thought we didn't need it here. So either it's going to be some, or we're going to return some kind of error saying there wasn't an expression, but there should be because, yeah. So again, it's very similar. We've somehow got to the end of the file without finding an expression. We're in the middle of, we've seen the open curly bracket. We've got to the end without seeing any further expression. So we got to the end of the file somehow unexpectedly. So that means now expr is not an option anymore, but it's still a result. So if we failed, that should also just result in an error. So let's just surface any error. I think we can just do it here. Or we could put the question mark here. There we go. So surely we can. All right. I wonder why we can't put that question mark there. Anyway, so we get an expression out. So basically look for the next statement up to a semicolon or a close curly bracket. If we got nothing, then we hit the end of a file unexpectedly. If we got an error, return the error. Otherwise, get the next token. If the next token doesn't exist, we've hit the end of a file unexpectedly, really unexpectedly, because this thing terminated. No, I guess this could have terminated without finding either of these, just hitting the end of the file. Anyway, we've hit the end of the file unexpectedly, so return. Now we know we didn't hit the end of the file. We did get another token after our expression. If that token was a semicolon, then this is just another thing to push into our return vector. If it was a brace close, then it's not just something to push into our return vector, although we should. It's also the end that we can stop looking, but we're not in a loop yet, so that doesn't quite make sense. Now we don't need this. Oh, let's say ret goes in here. We don't need this stuff, but I'm not quite ready to comment it out yet. Oh, sorry, I am ready to comment it out. I'm not ready to delete it yet. Okay, so now ret is the wrong type of thing. It should be a vec of box of syntax tree, but we are just making it a vec of syntax tree, which looks wrong. But yeah, like I say, these boxes are starting to make me very uncomfortable. I'm sure we can eliminate some of them by being more specific about the types, which is going to make our life better anyway. So where we've got to is we've expected like one statement, but actually there could be multiple. Now if we hit a brace close, this is not a statement. This is just an expression like this. The right number of brackets. But the other thing we need to do is stop looping. But we are not actually looping, so let's loop. So the loop is, I wonder whether we can do better than an infinite loop, because that always makes me very uncomfortable. But for now, let's think about whether the logic makes any sense. So we loop around. If we hit a brace close, not only do we push our answer into ret, we also break out of the loop. And if we don't at some point hit a brace close, we'll loop forever until we hit the end of the file. So I think that we will eventually quit either way. Now there's a whole load of code here for if we didn't hit a brace close, but I think that's okay. It's no longer the case that we just expect a closing brace now. We expect all kinds of stuff to happen, but the last thing that we expect to happen is a closing brace. So I think it's okay to just delete that. We'll see whether I'm right. We haven't got much error handling for these, so we might need to fill that in. So this is a long old method. So look for an opening brace. Look for a load of statements. Maybe that could be factored into a function. Because this is really quite similar to the code we had in parse next. Except if there was nothing, we got an unexpected end of file instead of returning none. Because I guess because that's an expected end of file in that case. We've finished parsing expressions and there's nothing more. So we should definitely think about how to reuse this code, but let's see whether we get any further with this test. Okay, we got further. We got a to-do. We hit a to-do. So what is this? A couple of tests failed. We hit a to-do for the parse empty while, which suggests to me it got through the stuff and then hit some later to-do. And then the parse while failed because it wasn't exactly what we expected. So let's have a look through what we expected and see whether it's just the spans being off or something like that. So we got a while with a syntax tree, blah, 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 operator less than or equal with a span from 8 to 2. And then on the left-hand side of it, we got a 1, span 6 to 1. And on the right-hand side, we got a 2, span 11 to 1. By the way, we should change these numbers and stuff to make it vary, like I always say. And then we got a block of statements, first of which is a syntax tree of an assignment with a symbol token of AB and a span. Oh, look, we got our spans wrong. Let's just fix our spans and see whether the rest of this stuff was what we expected. So where's our while loop? Yeah, so we were off by 1 on that. Should be 19,2. I'm happy to just accept that it got the right answer for this without checking it. What else? Then the 3 was 24.1 instead of 25.1. Consistently. And then the final thing was 27.1 instead of 28.1. I probably started counting from 1 instead of 0. So if we do that, only one of our tests fails. So the non-empty while succeeds, but the empty while fails because of a to-do at 531. Which is something about parsing a closing brace. We didn't consume our closing brace. Why does this only fail in one of our 2 tests? It's because, okay, I get it. So, let's try and talk this through. When we're parsing a while, what we do is we're parsing a block inside the while. We look for an opening brace. We find it. Then we look for an expression. And normally we get an expression terminated by a closing brace. We get the next expression and we get the next token, and if it's a closing brace, then we deal with it. But what about the case where there is no expression whatsoever? So we grab at the expression, ask for a closing brace, and we get back I guess, do we get back a none? What will expression do if there weren't any statements before we hit R? Or expressions or whatever. So the next token is either keyword, no, it's not a keyword, or it's a leave operation. And yeah, check token of type, that was the thing I was thinking of. And it gets hold of, so it's looking for a leaf token. It fails because it's not a leaf token. Or is it? Maybe that, no, sorry, close curly bracket, I guess it is a leaf token. So we go into a leaf or operation, and the first thing we do is get another token, and there isn't one, so we just return it, and we don't check whether end markers contain it, which is kind of interesting, isn't it? This feels like we should be checking this here as well as here. But either way, alright, and then we don't give it back. Yeah, I feel like there's a bug here, which is that if there is, no, it's looking for the next token. Right, so. We end up consuming 2 tokens, I think, here. Oh, is this fun, viewer? Is this fun watching me flail around? So token, we get hold of a token, and we have a look, and the token was a leaf token, and we come in here, we pass in the leaf token, we ask for another token after the potential leaf token, and we are assuming it must be an operator, because otherwise, so far the only thing we know what happened, the only time we would be able to have a token after a leaf token was an operator. Unless it was an end marker. But yeah, what we're not handling is the fact that this is actually an end marker itself. The first leaf token was an end marker, so I feel like we should actually be checking for that when we first pull it out, which is here. So if it's an end marker, we already want to quit. And I suppose return none, or return some kind of empty syntax tree would be the other option, which sounds a little odd. Alright, so following through, why are we getting this particular panic? That's funny, isn't it? So let's try and continue our reasoning. So we're in the middle of a block parse. We asked for expression, and we got back just the leaf token, which is brace close, without knowing that it was an end marker. So we hadn't pushed it back onto the stack. So we did get an expression, and it's not an error, but there's no other next after that. So I feel like we should be hitting this. But for some reason, instead of that, we're hitting, maybe before we get there, we're hitting this, which is, we're trying to make a leaf token. Oh, right, I see what's happened. Brace close is indeed a leaf token, but we're not actually successfully constructing a leaf token because we haven't actually written the code that does that. So we should have that code, but I think we've also found a bug with our expression which will cause us not to hit this code path. So let's fix the bug in expression, but are we happy? Do we need some kind of unit test for that first? What should we be returning? I guess we should be returning none, because there is no expression before the end marker. But it's not bad that this is happening. Let's look at where we call expression. So here we call expression, and if it's, and we don't care about it being none. What do we do with this? If it's an error, we return. Why is this not just a question mark? Oh, because it kind of wraps it up in sum. It's odd, isn't it? Anyway, if it's not an error, we get back expression. So expression might be hold on. Expr should be of type results of syntax tree. So it can't be none. Oh, that's why, because I'm completely misreading. No. Oh, no, we're unwrap. All right, so if we, yeah, okay. Parse next uses the fact that expression return none to return and say, I'm done. And it actually says there is no next syntax tree if expression return none. So if the first thing we hit was a semicolon, this would not work. So this is actually some kind of existing bug. We need expression to be able to say, I immediately hit an end token, not because I hit the end of the stream, but because I immediately hit the end token. So expression doesn't want to return none. It wants to return like there was nothing here, like some kind of unit. I guess it wants to return a unit value, something like that. So I'll need to write some kind of test that fails so that I don't forget this stuff, and then we can get back onto what we're actually doing. I think that's the right answer. Oh, we might need to fix this bug to make this what we're actually doing work. But either way, we need to write a test. So the test that we need to write is for parsing a semicolon that's just blank. So I guess the question is, what is the right behavior here? Let's look at what happens when I parse an empty expression or an empty statement. We should get back like an empty. We should get back a syntax. We should get back a syntax tree operation, syntax tree statement with like kind of a null expression inside it. So the expression here should be a box of some kind of thing, which means nothing. So I'm going to call it unit. And then I'm going to do this. Let's say to do handle empty statements. So just to make this test run and see what happens, what can we do here? Let's just be a bit silly and say it should contain a leaf node, which is an int that spans like something like that. Just I want to see this test fail before I ignore it. So it panicked an unexpected token, semicolon. But actually, parsing an empty statement is fine. So this I'm going to ignore. Can I? Maybe we need to fix this bug to fix our problem. Or maybe the easiest way to fix our problem is to fix this bug. How hard will it be to fix this bug? Let's just say, instead of it being a leaf, let's just say a unit, and that means we need a method called unit on syntax tree, or not a method, associated function. Is this the first thing in a syntax tree? It's the simplest type of syntax tree. A unit is just a syntax tree with a syntax node of type unit, which has nothing in it, maybe. Make a variant called unit, put it at the beginning to match what we just, where we put the method, associated function. And a load of things don't handle units, and some of these are going to be really painful. So unit is a syntax tree which has type unit and doesn't do anything. So we can just put a load of to-dos in for now and think about it later, but I think in general evaluating unit just does nothing, right? And type checking unit will need some thinking, because the type of a unit value is the unit type, so that's going to come. But for now, we'll just do a load of to-dos. Okay. So now my test that I've written is accurate. When you parse this stuff, you should get a statement with unit in it, and that's just for luck. Let's also make multiple empty statements. Just so that we don't end up implementing this in a way that only works for one. This should look like a list of statements which are all empty, like so. What have I done wrong? I've got an extra bracket. No, I've got a missing bracket in multiple places. Makes more sense. Right. Okay, what's it warning about? Okay, just stuff that's not used. So these tests still fail because we haven't fixed them, but now we have the types to express what should happen. Now we're going to fix our parser so that if, when we're looking for an expression and we immediately hit the end thing, like here, so we're going to say if end markers, can we do contains? Sounds like it. Token.kind. Then immediately quit with, maybe this can be all one expression like this. we don't need a return. We can say it's a sum of an OK of a syntax tree of unit, like so. So let's just say we immediately hit an end marker. So this is an empty expression, something like that. Okay, is this going to make our test pass? Any of them? None of them. Okay, so we hit a semicolon. So this isn't just a unit. This is, oh gosh, what on earth's going on there? Oh, I tell you what, we need to push that token back. Tokens dot. How do you push? I did this somewhere. Give back. Anytime we detect that we've hit the end marker, we need to then give back that end marker because we look at it later. So that might fix some of the problems I just saw. But yeah, this thing is not just a... Oh yeah, so expression is just going to return a unit, but then where we're using expression here, it's going to be a statement. It should be a statement. And our tests are saying it should be a unit, but actually that's wrong. It should be a statement. I think that's where it's going. So it's our tests that are wrong. No, our tests are saying it should be a statement. And we're getting back a unit. Why? So expression should be giving us back a unit. But when we get back here, we should find this semicolon and say, because we did the give back, right? So we should be getting this, and somehow we're not. Just one more go at running it in case I've changed something since then. Oh yeah, I fixed most stuff. By that, yeah, the give back was the key thing there. We gave back the semicolon, which meant it got detected, so that's all fine. Right, so what is our problem here? Yeah, the problem here is the empty while now actually consists of a unit statement inside that while loop, which may not be actually quite right, because I would expect there to be a unit expression or a unit in there when there's a semicolon, but I kind of expect that there wouldn't be one when we've just got two curly brackets. It's like, that's more like an empty list. There's no expression in there. And it's less like a unit. On the other hand, generally an empty block will return unit. So I think we can tolerate this for now. And if it causes problems later, we will find a way to fix it. But I think we can say an empty while loop block actually consists of one unit expression as opposed to like nothing at all. And of course this is interesting, but that makes us think maybe my first formulation of this, where I said this was a vector of statements plus an expression, which always existed, was a better formulation, because if this vec is never empty, that's an invariant that is really hard to enforce. It would be better for us to have a separate thing saying, okay, the vec can be empty because the statements, there might not be any statements, but there will always be at least one expression at the end, which is sometimes this unit expression. So let's think about that refactoring if we can get our tests to pass. So all our tests are passing. Let's go back to our example test. Are we ready for our example test to pass? Oh no, well, not for evaluation, but maybe for parsing. Okay, so actually our example is now failing on parsing an expression which modifies a variable. We've never done that before. We've only done an assignment, initial assignment of a variable, not a modification. So that's cool. That'll be the next thing we work on, but it's definitely not part of what we're doing right now. Our tests all pass. So the only question we're left with is, do we think block should consist of a list of statements plus an expression at the end? I think it should, and I think when we make our types more specific, that will become clear, and we'll be making our life hard if we don't account for it now. So let's make that refactoring. Let's say that a block is a list of statements and a final expression, which is a box of, well, for now is a box of self, like this. And syntax node block should have a thing called final expression, which is a box of t. And then there's a million compile errors, including this one, which is all just to do, so we don't have to actually implement anything yet. And this one takes in, all right, so how is this going to work? So basically, when we hit the closing brace, we no longer push this into our return value. Instead, we have this other thing. So let's rename ret to statements. And final expression is going to be somehow, it's be weird. We need a function really to yeah, so why don't we extract this into a function? Is it going to let us, since we're not compiling right now? Okay, and this function should be called, or method should be called, for now we'll just call it block statements. And it should be let statements, comma, final expression equal that, right? Then we can pass that in. And we're going to construct that vector in here instead of passing it in. And it's going to return a result of vec of box of syntax tree, I guess. What is it, T? No, syntax tree, comma, box of syntax tree, which is going to be more specific because it's going to be expression, not just a thing, but we haven't done that yet. So, how are we actually going to construct this? So we've got a mutable thing called vec, which we're building up gradually. No, we're called statements. And the only way that we actually return successfully from this function is so when we hit a semicolon, we just push the thing into statements. When we hit a brace close, we return statements and our final expression. And now we don't need a break, and I never like having breaks, so that's good. And there should be an OK around it. I don't like having early return, like mid method returns either, so I'm not that happy. And that means this OK goes away. And that's the only place where we return. Oh, we should do something. I didn't notice that we'd not done something here. So we shouldn't panic. We should do some kind of error like we did in another place where we had this. To do should never happen, but we should handle as an error. Unexpected token after is in a block. So we've called expression. We told expression the only things that you can stop with are semicolon or closing brace, and we know that it pushes that back, so it should be there. We get it out. And it wasn't a semicolon or a brace, so this should never happen. But it's sufficiently far away from the code that guarantees that I want to handle that as an error, not just as a panic, I think. Right, so yeah, this should be an empty vector followed by a unit syntax tree. So basically we're saying a while loop now with an empty thing consists of no statements and one unit expression. And a while loop with stuff in consists of, like how we originally wrote this, it's a vec of one. Is that going to just be okay? Yeah, it's a vec of one statement that let a be equal 3 and then one expression at the end. Must be more stuff, yeah. Okay, so another thing that's just a to-do. And another. Be good when we've implemented some of these to-dos, won't it? And last one. Right, do our tests still pass? They do. Okay, so just to recap, we're done for today. Just to recap what we've done. We have managed to get not all of this to parse because this bit still doesn't parse. But in our simplified example, which is here, we are now able to parse a while loop with a keyword and then an expression and then what we're calling a block. And a block consists of a bunch of statements and then it ends with an expression. And if there's nothing between the curly braces, then it consists of no statements, but it still ends with an expression. That expression is of type unit. And so I guess if this ends with a semicolon, the expression should also be of type unit. So I guess we should write a test for that. But I've done enough for today, I think. Too much in one video. But yeah, so that's the definition of a block. And I think the definition of a block is going to be quite helpful to us because it's part way to what a function is. Right? A function body is quite a lot like a block. So that would be good. But yeah, things that we need to be able to handle is that while loops can actually return values and certainly blocks can return values, and we need to have that. I think the building blocks for that are in place, but we need to make it actually happen. But next thing coming up is that actually, as I said, we haven't actually allowed you to modify a variable. We haven't got the parsing in place, let alone the evaluation in place to modify X. We've only done let statements before, these assignment statements. These are, I guess we might call them mutation statements or something like that. And that doesn't even parse yet. So our next job to make this little code snippet work will be these types of statements. Hope you enjoyed. See you next time.